Okay, I hear the recording in progress. So share the screen here. All right, so we're here. Welcome to November. We're getting near the end. And I was already done with 4.8, so all we have left is 4.9 for this entire week. And so that being the case, we're considerably ahead. Probably don't have to have too long of a session any of these days. So our next exam is Friday. Usual rules for exams, so you should know the spiel by now, but I'll just repeat myself. So you're responsible for 4.2 to 4.9. This is what you should study, and this is the homework that you should turn in with a few exceptions, as you can see here. Okay. And for the exam, you're allowed one formula sheet, one cheat sheet, and a calculator, but nothing else. Okay, so as usual, I will send the exam by Canvas announcements a little bit after 9 o'clock, and you will join the Zoom session. Attendance at the Zoom is mandatory, so all the other days are optional. I know some of you come all the time, some of you come none of the time, some of you half the time, that's okay, but you do all have to show up for the exam day, right? Have your camera on, true background, first and last name as on my roll sheet, good stuff like that. You should know how that works. And then class ends at 10 o'clock. I'll close the Zoom at 10. You have until 10:05 to take pictures on your cell phone. And then you have until 10:30 to submit the homework, although I'll take the homework early. As soon as class is over on Thursday, I'll start accepting the homework. Okay, looking much farther ahead, we actually have 3 more exams, but we're much closer to being done than you might think, even though we have 3 more exams. The next exam is very quick. Only 3 sections. It's on exponential and log functions. And then after that, we have something on conic sections, the parabola, the ellipse, the hyperbola, stuff like that. And then we're done with the course. So we've got quite a few exams coming up. So exam 4 this Friday, and exam 5 the 19th in only 2 weeks. Okay, and then our last exam, well, I'm not sure if I'm going to keep it on Thursday the 9th. I don't have to. I can move it back here, but I'll let you know. Okay, it looks like our final exam is the first day of finals, that very Monday the 13th. And please note the time of the final exam is 8:10 to 10:40, not 9:10. Okay, we start at 8:10. Now, I mean, if you want to join at 9:10, you may, but that means you're going to have less time than everybody else. And so you may not want to do that, obviously. Okay, so that's where we're at. We're getting very close to the end. It's already November. So we do have 3 more exams. Okay. The big major exam we have is the trig one, as you can tell. But after that, 2 much shorter sections. Chapter 5 is very short. In fact, chapter 5, it looks like it's the smallest. Yeah. And chapter 6 isn't that long either, looks like. Okay. Let me check the chat. How many questions will be on the final exam? Okay, well, let's see. I normally give you about 10. So fair for the final exam might be around 20-ish. And you get 2.5 hours. So offhand, I would say maybe around 20 for the final exam. And for the final exam, you can have all the previous formula sheets. So rather than making a brand new formula sheet, you're allowed 6 cheat sheets. How about just keep, hopefully you didn't throw it away. But if you got the cheat sheet from the first test, second test, third test, this coming test, and then one here and one here, why make them all up again? Just bring them all. You're allowed to have all of them. Now, if you happen to throw it away, you can go back and make it again, I guess. But and by the way, you're allowed to add stuff to it. So when you take a test and maybe you say, oh, I wish I put that on my formula sheet, right? Or I wish I put this in. You can go ahead and add more stuff in if you have more space on your paper. So that's fine. Okay. All right, I'm actually going to mark this off because I was done with 4.8 as far as I was concerned. Let me double check that. Yeah, I think I did everything I needed to for 4.8. Of course, as we go along this week, we're practically done. You may go ahead and ask questions for review in preparation for the test. It's our longest chapter. It's trig. Trig is often a bugaboo for students, no question about it. And of course, we all have different trig experiences. And some of you maybe had trig just last semester. Some of you haven't had trig in a while. And so, you know, you're at different levels of what should I say, freshness of your trig. Some of you, it's still fresh from last semester, and some of you haven't done trig in years, so it's different. But anyway, that's why I let you have a formula sheet to put everything down. Okay, so let me get started with 4.9, unless there's any other quick questions for 4.9. So I have the whole week to do it, so I'll probably end fairly early today and tomorrow and the next day and the next day, and I'll just let you ask a lot of questions. And yes, chapter 5, it doesn't look like there's a whole lot of time. Oh, only 2 more weeks, but it's very short. There's only 3 sections. And as you know, the holidays are approaching. So we have a Veterans Day coming up. We got Thanksgiving. So we actually have fewer days than you might think. And then before you know it, we're all done for the holidays. And then there we go. Okay, any other general questions before we start? All right. 4.9. 2 main formulas, law of sines and law of cosines, page 261. Here is the law of cosines. I would say, put this on your formula sheet. These are equivalent. Okay, they're just changing the letters around. Okay, but convention for the triangle. We're now dealing with any triangle. It does not have to be a right triangle. In general, it won't be. Okay, sides A, B, C, and A, B, C, alpha, beta, gamma. To me, alpha, beta, gamma are unnecessary, but you can just call them A, B, and C. But anyway, the angles are alpha, beta, and gamma. Those are the first 3 letters of the Greek alphabet. So A for alpha, B for beta, C is gamma. It's the equivalent of G in Greek. And please notice this convention. You should hold to this convention. Big A is opposite little a. Big B is opposite little b. Big C is opposite little c. So capital A, B, and C are the points. I would even say they're the angles. I don't think you need the alpha, beta, gamma, but anyway. The little letters, A, B, and C, are the sides. And there's always an opposite convention. So big A opposite little a, big B opposite little b, big C opposite little c. Alpha, beta, gamma. Okay, and you can prove, I won't prove it, maybe your trig teacher proved it, this law of cosines, a squared equals b squared plus c squared minus 2bc cosine of alpha. Okay. These two are equivalent. Okay, if you stop and think about it, okay, one side squared is equal to the sum of the other 2 sides squared minus 2 times b times c times cosine of the angle associated with A, which is alpha. Notice the same pattern. So do you want to put this on your cheat sheet? It's up to you. If you know how the pattern goes, right? This one starts with b squared, but can you guess from the pattern? It's up to you. If you want to put it on your cheat sheet, you may. But I would say, okay, if I put b squared, right? What I'm going to put here, you have the 2 letters, a squared, b squared, minus, then follow the pattern. You would have 2ac cosine beta. And similarly, how do I find c squared by the pattern? So you put the other 2 letters, c squared is a squared plus b squared, minus 2, follow the pattern, 2ab, then cosine of, let's see, a alpha, b beta, so cosine gamma. So you can put one of these or all 3 of these. If you're more comfortable putting all 3, that's fine. I think you can survive just like that. A heads up, if we were meeting face to face or the last time I taught this class, my students had to memorize it. Okay. Your next teacher might make you memorize it, especially if we get back to being on campus next semester, not sure, or sooner or later we'll all be back to campus. Your next teacher might make you memorize. It's just a heads up on that. Okay, they go over a little mini proof of it. You can look at it or not, but just go with it. Law of cosines. Law of sines is a much easier group, page 264. Here's a picture again. A, B, C. Notice opposite, little a, little b, little c. alpha, beta, gamma. Much easier formula. Sine of alpha over A equals sine of beta over B equals sine of gamma over C. I would dare even just say sine A over A, sine B over B, sine C over C. Put this on your formula sheet. It is provable. The text goes over a proof of it. I'm not going to look at it. I'm not holding you responsible for it. Just be able to use it. So homework problems in this section deal with that. 4.9. Law of sines, law of cosines. Now, of course, you might say, well, how do you know which one to use? Well, which one looks easier first? Does this look easier? Or this one? That looks a little bit harder, right? And all this extra stuff. This looks easier. Perhaps the best way to say it is our preference is to use the law of sines, but maybe you cannot use it. If you cannot use it, use law of cosines. Then, of course, the question is, well, how do you know you can't use it, right? Okay. One thing you can think of is you can start with this and you might get stuck. If you get stuck, then switch to the law of cosines. Okay. And I'll have to show you what I mean by how do you know if you get stuck. Well, first of all, sometimes the directions tell you right away what to use. So it might say, use the law of cosines, then automatically you know what to do. Or use the law of sines, problem 5, and whatnot. Okay, and go from there. Or it might say use law of cosines or law of sines, and so forth. Okay. Let me try to give you an important principle. Let's see. Let me show you the law of sines. Let me temporarily call this A, B, and C. Sine A over A, sine B over B, sine C over C. Okay, pretend it says something like that. In order to use the law of sines, the information that they give you must have 2 of one letter. In other words, you have to have A and A, or B and B, or C and C, or you can derive it. Okay, what do I mean by derive it? Well, we're going to use the rule, of course, that the sum of the angles in any triangle is 180 degrees. You should already know that, right? So for any triangle, alpha plus beta plus gamma is 180 degrees. And yeah, one other quick word. In this section, we're primarily going to be in degrees, not radians. So if you need to change on your calculator to be in degree mode, switch to degree mode right now, not radians for this section. Now in the exam, you have to be ready for both modes. You have to be ready for degrees and radians. Okay, so you might have to switch back and forth. So I'm going to switch my calculator out to be in degree mode right now, as you can see. Right, so the 3 angles always have to add up to 180. Then to use law of sines, they either have to be able to give me A and A, B and B, or C and C. Otherwise, you're stuck. If you're stuck, switch to law of cosines. Okay, now you might start off a problem using law of cosines, and then once you have enough information to get to this, you might switch over to law of sines. I mean, that's allowed, since the law of sines is usually an easier problem. Okay, now most of the time we're going to be solving a triangle. And so solving a triangle. What do you think it means to solve a triangle? Give all the sides, give all the angles. Solve a triangle. Now, a triangle has how many sides? 3. How many angles? 3, right? So, like our standard picture would go 3 sides, little a, b, c, 3 angles, capital A, B, C. Normally, they will give us 3 pieces of information. Okay. So normally they will give us like 2 angles and a side, or 2 sides and an angle, or 3 sides, something like that. Based on that information, can I figure out the rest? So I can identify the rest of the triangle. Okay, so normally they give us 3. See if I can show you examples of that. Page 271. Yeah, well, madam, why don't I just give you all the problems? How far do we have to go up to? 25. Yeah. So page 271, for those of you who don't have the book and aren't getting it, while I'm showing it to you, notice they give you 3 pieces of information, right? Angle, a side, and a side. Angle, side, and a side. Or angle, angle, and a side. Angle, angle, and a side. Or angle, side, angle, and so on, right? Some of you might recall these congruences from high school geometry. Remember in high school geometry, you did a lot of side, angle, side, and angle, side, angle, and side, side, side. Remember that kind of stuff? That was part of it. And it looks like you have some word problems here, but it's not really that big a deal. So there's that. 21. Whoops. 3. And there's 25. I'm going to show you the words down there also. Yeah. Okay, so I think that's all there. So let's get our feet wet. Okay, use the law of cosines to find the remaining side and one of the angles. Okay. So let's just basically solve the triangle. Right. Here's my spiel on the whole thing again. So law of sines, law of cosines. And we also have to do an area of a triangle. And by the way, you might say, oh, I already know the area of a triangle, 1/2 base times height. Yes, but it may not be written that way. It may be given in another format, and I'll have to show you that when we get to it. Law of sines, sine of alpha over A equals sine of beta over B equals sine of gamma over C. Much easier than these. Law of cosines, A squared, B squared plus C squared minus 2BC cosine of alpha, or the equivalent. What do you mean by the equivalent? You just change the letters around. B squared by itself, it's the other 2 squared, or C squared by itself, the other 2 squared, minus 2 times that, 2AC. In this case, it's 2 times that, 2AB. Cosine of whatever you see here. So cosine alpha, cosine beta, cosine gamma. Okay, and we're going to be solving the triangle. Solving the triangle. Okay, before we do that, here's an important principle. You might want to put this on your cheat sheet. The smallest side is opposite the smallest angle. The largest side is always opposite the largest angle. And if you stop and think about the reasoning, that makes sense. Take a look at this picture. Okay, theta is very small. I have my 2 pens, real small angle right here. Then the side here is small. But imagine if I open it up, if I take my pen and open it up like this, right? The angle right here is getting big, then this opposite side is also getting big, right? So when this angle gets bigger and bigger, then that opposite side gets bigger to the point. So important principle, the smallest side is opposite the smallest angle, the largest side is opposite the largest angle. So if that's ever violated, then something's wrong with our calculation, something went astray in our work, okay? All right, so I'll set you up with number 1. Ignore all the red stuff. The red is the new stuff. What's given is alpha is 55 degrees, B is 12, C is 20. So what do they give me? 2 sides and an angle. Okay. If you're given exactly 1 piece of information for each letter, the law of sines won't work. Okay. So in other words, I have exactly 1 piece of information from A, B, and C. I have an angle A, side B, side C. Law of sines doesn't work. Okay. You can see that if you set it up, ignore the 16.39. But sine of 55 over A, sine of beta over 12, sine of gamma over 20, I'm stuck. I cannot work with this information and get anywhere. So I have to use the law of cosines. All right, now how do you know which form do I need? Well, you're given angle A, you go opposite little a. Okay, so I'll use a squared equals b squared plus c squared minus 2bc cosine of alpha. Do they give me b? Yes, 12. Do they give me c? Yes, 20. Minus 2bc. This b is the same as this b, 12. This c is the same as this c, 20. And then the cosine of 55 degrees. Okay, so punch everything in. A squared is 12 squared plus 20 squared minus 2 times 12 times 20. Cosine of 55 comes out to be this approximately. Okay, and I'll just confirm that on my own. I do want to make sure you're in the right mode. So when you guys are doing this, make sure you're in the correct mode. Right now, we're only doing degrees. Okay, so let me try it myself. 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 55. 268.68. 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 55 degrees. 268.68. That's a squared. So I hit my square root, right? So square root 16.39. That's a. So where to go? Put that at 16.39. Now that I have a, now that I have that, I can switch back to law of sines if I wish. Okay, so what did I do? I put these together. Sine of 55 over 16.39 equals sine of b times 12. And normally when you get this, you can cross multiply. Get ready to do a lot of cross multiplication in this section. Okay, so that times that equals that times that. 12 sine of 55 equals 16.9 sine of beta, divided by 16.39. So beta is, sine of beta is this. So beta is inverse sine of 0.5997. Okay, so let me just punch out 12 sine 55 divided by 16.39. .5997 roughly. So beta is the inverse sine of that. So let me hit inverse sine, second function, inverse sine of my answer. 36.8 degrees. And once I have two angles, don't bother doing any of this law of sines and law of cosine stuff. Just use the fact that these three have to add up to 180, right? So now that I have 36.8, and this is 55, just subtract from 180. 88.15. So 88.15 degrees. And the triangle is solved. And a quick check. Largest side, largest angle. Smallest side, smallest angle. Yes. It works. All right, so that's a general procedure. This kind of problem. Let me review one more time. I have to use law of cosines if given exactly one piece of information for each letter, one of A, B, and C. To use the law of sines, you need two pieces of information from a single letter. Here they gave me exactly one A, alpha, one B, and one C. So no good to use law of sines, law of cosines. Use the law of cosines to find A. Once I have A with 16.39, I'm allowed to switch back to law of sines if I want to, which is what I did. And let's see, I aim first for beta because I know beta is going to be the smallest side. Now that I have 12, 16.39, and 20. So I find beta. Once I have beta, I can find gamma because these three have to add up to 180. All right, folks, I was only going to show you one more, and then I'll be done. We have time to do more Tuesday, Wednesday, and Thursday. Number 5, use the law of sines to find the remaining sides. Yeah, they told you to use the law of sines, but they didn't have to say that. But anyway, be that as it may. Okay, alpha is 40, beta is 87, C is 115. Aha. First thing you should notice right away, I have 2 angles. Once I have 2 angles, can I automatically find the third? Sure, right? Because you know all 3 angles have to add up to 180. And then once I have that, it looks like I can switch over to law of sines. Okay, so 87, oops, 40. And so gamma is 180 minus 40 minus 87, and that comes out to be 53 degrees. So gamma is 53 degrees. 40, 53, 87. Now that I have all that information and I have C, switch to law of sines. Sine of 40 over A, go opposite. Sine of 87 over B, opposite. Sine of 53 over C, opposite 115. Here's the key fraction. This one I have both pieces of information, a side and an angle. So I can cross multiply to find the rest of the stuff. Okay, so how about ignore the middle? Use this fraction equaling this fraction, cross multiply. A times sine of 53 equals 115 sine of 40. Cross multiply that times that equals that times that. Divide by sine 53. Went to the machine, 92.56. That's my A. Yeah, let me just see if I can duplicate that for you. Show you that. So what was it? 115, 115 sine 40 divided by sine 53. (92.558), 92.56. Okay, so that takes care of that. And then do the same thing to find B, and then I'm done. So now I'll just use these two. You have to use this one because this fraction, you have both pieces of information, right? Sine and angle. So cross multiply that times that times that. So B sine of 53 is equal to 115 sine of 87. Divide both sides by sine of 53. So B is 115 sine of 87 degrees over sine of 53 degrees. And that supposedly comes out to be 143.80. Let me try to verify that. 115 sine 87 divided by sine 53. 143.798 means 143.80. So there we go. So the triangle is solved. They normally give me 3 pieces of information. You figure out the other 3. So gamma is 53 degrees, A is 92.56, B is 143.80. The triangle is completely solved. I have all the sides, I have all the angles. And quick double check. Smallest angle, 40. Smallest side, 92.56. Yep. Largest angle, 87. Largest side, 143. Yeah, it works. Okay, I'm just about done, folks. One last thing I want to mention as a caution, though. Okay, no, you know how we said, oh, if we ever have two angles, you can automatically find the third, right? Because we have to add up to 180. How about you say, wait a minute, if I have two sides, can I use the Pythagorean theorem to find the third side? Right? A squared plus b squared equals c squared. Can I use the Pythagorean theorem? Once I have two sides. So way back over here, right? I got A, I already had C. So you might say, rather than doing all this extra trick, why don't I just do A squared plus B squared plus C squared? There's a good reason for that. A squared plus B squared equals C squared only works for what kind of triangles? Right triangle. We do not have a right triangle. Therefore, you cannot do the Pythagorean theorem. Okay? Common mistake for some students. Okay, where they find two sides and say, oh yeah, I'll just do the Pythagorean theorem. You cannot do the Pythagorean theorem if you do not have a 90-degree angle. And in this case, you don't. Okay? So sometimes you might not. You can't assume that you have it. So Pythagorean theorem cannot be done. You can only use the Pythagorean theorem if you know for sure one of the angles is 90 degrees. If I can't derive that, or you can derive that it's not possible, then don't use the Pythagorean theorem. So yes, the only way to do this problem is what we did, to use the law of sines to figure everything else out. Okay. All right, folks, I've done my quota for today, and I was going to start with okay time-wise. I got you started, give you the formulas, told you what to put in the cheat sheet, and I can do more, tomorrow, Wednesday, and Thursday as necessary for the test on Friday. Okay, let me stop the share and check the chat. See if anybody else has anything. Okay, I don't see anything right now. Okay, any other questions? Otherwise, I'm going to call it a day. All right, that'll do it for today, folks. Okay, so have a good day, and we'll see everybody next time.
Thank
All right,
you.
bye, everybody.